Today we're going to start looking at section 2.5, which is called transformations of functions. So our objectives today, we're going to recognize graphs of common functions, and then we're going to use vertical and horizontal shifts to graph the functions. So we've been graphing functions since chapter 1, but we're going to be doing a little bit more with the information. So I know you have an online textbook. We're in section 2.5 on page 242. There's a lot more information about the graphs, but I just want to kind of show you really quick. Anytime they have a constant function, it is going to be where we essentially have a slope of 0, okay? Constant means it's not increasing or decreasing, it's staying at the same rate. So that would be this horizontal line here on the left. Okay, to be an identity function means that the value that you substitute in for x gives you the value then for y that's the same. So here, notice that it was a straight line because when I plug 1 in for x, I get 1 for y. When I plug in -2 for x, I get -2 for y. So it is just a line there, but it has to go through the origin. We have absolute value functions. Okay, we've talked about those in chapter 1. Remember, it forms a V. We have our quadratic function, which is the shape of a U. So remember, quadratic is our degree 2, so our x squared. We've talked about square root functions. Remember, because we're dealing with square roots and we are graphing on a coordinate plane that has real numbers, I can't plug in numbers underneath the radical. That would turn my square root then a negative underneath, because then that would be an imaginary number. So that's why in this particular function, if it's just the square root of x, the first number that works underneath the square root would be 0. So that's why it has to start at that point. And then as we continue to plug in positive numbers, we can get more values, but negative numbers would not work in that particular function. So just understanding the basic shape of those graphs again is going to be important. Notice how we also have a cubic function. So an x to the third power. Okay, you can square negatives, you can square, or not square, but you can cube negatives, you can cube zeros, you can cube positives. So it looks something like this. There's a curve to it. And then we have cubed root functions. So notice how it basically looks like a cubic function, but it's turned on the side. Because remember, we can have negative numbers underneath odd indexes for our radicals. So that's why we aren't going to be starting at a specific number. We can hit negatives, we can hit 0, we can hit positives. All right, so now let's get into this idea of vertical shifts. So it says let f be a function and c be a positive real number. So here I've got a graph. It says y equals f of x plus c is the graph of y equals f of x shifted c units up. So my original function is what is in black. And if I'm adding c onto it, I'm shifting it up, whatever that value of c is. If I have the graph y equals f of x minus c, well, it's the graph y equals f of x, but then it's shifted down that value of c. So once again, my original function is here in the black. My new blue function is us shifting down because we are subtracting a value from the function. Okay, so notice that adding or subtracting numbers outside of that original f of x function is going to be moving the graph up and down, which is why we have these vertical shifts. Horizontal shifts. It says let f be a function and c be a positive real number. The graph y equals f of x plus c is the graph of y equals f of x shifted c units to the left. So my black graph here is my original function, y equals f of x. Notice how because I'm adding c inside of the parentheses, it's included with x. Now, anytime I'm doing horizontal shifts, I actually want to think about the opposite. So that's why, because it says plus c, I'm moving to the left. Okay, so we're thinking the opposite. So whatever we're adding there, we're moving it then that many to the left of that original function. So then if the graph y equals f of the quantity x minus c is the graph of y equals f of x, it's shifted to the right because once again, because I'm subtracting c inside of the parentheses, that indicates that I am moving in the opposite direction. So I'd be moving to the right because horizontal shifts move left and right. That deals with the x values. Okay, so let's use that information and let's graph this. So here we are giving you the original graph of y equals f of x. We are now going to graph this new function, g of x equals f of the quantity x plus 2 minus 1. So I would suggest that you pause the video, plot those points, connect them to form this f of x graph. Make sure that you label it f of x, and then we'll start talking about the g of x function. Okay, so remember, anytime I have a number inside of the parentheses, that's going to help give me a horizontal shift. And we are always thinking about going in the opposite direction of whatever the number is. So since I see a plus 2, that tells us that we want to shift 2 to the left because I'm going in the opposite direction. So any numbers inside the parenthesis, change the sign. That's the direction that you want to head. When we're dealing with numbers that are outside, well, that's going to then be a vertical shift. And we keep the sign the same. So since it says minus 1, that's going to tell us that we are going to shift 1 down. Okay, so that's what I'm going to do with each of these ordered pairs. I'm going to move 2 to the left and 1 down and plot that new point. So I'm going to start at this negative 4, 0. I'm going to go 2 to the left and 1 down. Here's my new point. Now I'm going to go up to this negative 2, 4. I'm going to move 2 to the left, 1 down, plot my point. From the origin, I'm going to go 2 to the left, 1 down, plot my point. From the point to negative 2, 2 to the left, 1 down, plot my point. And then from 4, 0, go 2 to the left, 1 down, plot my point. So now I can very carefully connect the points. It should look exactly the same. Okay, the function itself hasn't changed, it's just shifting. So now this, I'm going to label it, is my g of x function, and that's my graph. So we just really had to understand how did we move left and right and up and down based off of this new g of x function, plot those new points, and we've got our graph. So I would suggest that you pause the video, plot this original function f of x, then I want you to graph the function g of x equals f of the quantity x minus 3 plus 2 on the same graph, label it g of x. Okay, so hopefully you should have gotten something like this. Obviously, my graph kind of went off a little bit on the right, but because I have x minus 3 in parentheses, that tells me that I'm going to the right 3. Because I'm adding 2 outside of the parentheses, I'm moving up 2. All right, so let's still use that idea, but now let's start looking at some of our functions that we've been graphing since chapter 1. So we're going to graph the standard quadratic function f of x equals x squared. So essentially, this is what I call a parent function. Okay, I know that it is a squared function, so I know that my graph should look like a U. There aren't any shifts involved, so I can very easily graph this. Now, I'm going to make a table of values. So I'm going to have numbers for x, and then essentially what's happening is I'm substituting them in to the x squared portion. So I'm going to do some negative numbers, 0, and then some positive numbers. So if I square negative 2, I'm going to get positive 4. If I square negative 1, I'm going to get positive 1. Squaring 0 gets me 0. Squaring 1 is 1. Squaring 2 is 4. So those are the ordered pairs that are part of this original parent function, f of x equals x squared. So I'm going to plot those points. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. I'm going to connect them. I'm going to put arrows on either side. I'm going to label my function f of x because we're going to have two graphs on this function. I need you to label so I know which one is my original and which one is my graph that happens with these transformations. Okay, right now, you could probably very easily do what we just did with the last two problems. You can see this g of x function has two different shifts involved. We can identify those shifts, and then we can go ahead and from our original parent function, we can move those points. And I'll show you that. But then I'm also going to show you how you can finish it up with the table, because eventually we're going to be getting to things where there's going to be a lot of shifts involved, and creating a table of values might help you out and allow me to see your thought process as you're trying to do all the shifts. Okay, so I'm going to do it in a different color. Notice how I have a -1 in parentheses, so that tells me it's a horizontal shift. Because I'm subtracting 1, I know I want to do the opposite, so that means I'm going to move 1 to the right. And then because I've got this +3 outside, I'm going to then move 3 up. Okay, so if I did just like we did on those other ones, I'm going to go to my original point. So I've got -2, 4. I know I'm moving 1 to the right and 1, 2, 3 up and plotting my point. From the ordered pair of -1, 1, I'm moving 1 to the right and 1, 2, 3 up. From 0, 0, 1 to the right, 3 up. From 1, 1, I go 1 to the right, 3 up. And then from 2, 4, I go 1 to the right, 1, 2, 3 up. So then here is my second graph on the same exact graph. I'm going to label it over here. There's my g of x function. So I have both functions on the same graph clearly labeled. I just want to show you how you would do it with your table. Because the number that's inside the parentheses is dealing with moving left and right, well, moving left and right is on the x-axis. So that's why here I'm going to then have to add 1 onto x. So I guess instead of writing it there, I'm going to write it over here. I'm going to have to add 1 onto x. And so if I do -2 plus 1, well, that's -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So those were my new x values. And I can once again reiterate that once I finish this. Okay. Then, since we know that we were moving 3 up because that's our vertical, that means that the x squared term, which was our y values, that's dealing with moving up and down, I knew that I had to add 3 onto that. So 4 plus 3 is 7, 1 plus 3 is 4, 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7. So technically then -1, 7, notice that, -1, 7, that was a point that was on this g of x function. 0, 4, another point on our function. 1, 3, point on my g of x function. 2, 4, 3, 7. So that's why creating a table of values will get you the same answer as if you just think about it moving left and right and up and down at this point in time. All right, let's take a look at another example. So we are dealing with a standard absolute value function, f of x equals the absolute value of x. So once again, I call this my parent function. There are no shifts involved. I know because it's an absolute value, we should have a v. So I'm going to create a table of values to then have my, to have my points that I'm going to plot on my graph. So absolute value, you can plug negative numbers in, you can plug 0 in, you can plug positive numbers in. Absolute value of -2 is +2. Absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So those are my points that are going to be on this parent function f of x. So I'm going to plot those. -2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. So if I start then connecting those points, here is my function. I'm going to label it. Here's my f of x function. Okay, now on the same graph, I want to graph this g of x function. So notice that I've got a number inside of the absolute value. So if it's connected to the x, that's going to represent a horizontal change. And so that means I'm moving left and right. And so with my x column in my table, I want to do the opposite. Since I see +1, I know that I really want to subtract 1. So I'm taking -2 minus 1, I'll have -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. So I know those are going to be the x values of my new ordered pair. So we think the opposite anytime we have a number that is connected to the x. When I have a number that is not connected to the x, I'm going to keep the sign the same because that's dealing with the vertical shifts. That's dealing with the absolute value of x, which is my y values. I am going to just add 4. So 2 plus 4 is 6. 1 plus 4 is 5. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. So the ordered pairs that we're plotting for my new g of x function are -3, 6, -2, 5, -1, 4, 0, 5, 1, 6. And then I can connect those. And I'm going to label g of x. So once again, you can, from your original points, just go over, we had to go 1 to the left and 4 up, and that's how we got the ordered pairs that we got. So I would say pause the video. We've got our parent function, f of x equals the square root of x. So think about what numbers you can put under a square root to start your table. And then you're going to do the transformation graph, g of x equals the square root of x plus 5 plus 2 on the same graph. Please label your graphs. All right, so notice that because the 5 is underneath that absolute, or not absolute, but the square root, I know that I needed to move 5 to the left, so that's why I subtracted 5 from x. And then because the 2 is outside, I am adding it onto the y values. Notice that because we're dealing with the square root, I had to, with my original function, start at 0, and then I picked perfect square numbers so I could have nice ordered pairs. I labeled both of my graphs. So that's us recognizing graphs of common functions and using vertical and horizontal shifts to graph the function.